All right, class, today we're going to talk about polynomial functions of a higher degree, which is found in section 2.2, part 2. Our objective is to find and use zeros of polynomial functions to sketch their graphs. So for example 6, it says to find the polynomial functions with the following zeros. And there are many correct solutions, so I do want you to know, in case you're not getting exactly what we're getting, there are many options. All right, so first of all, we have, these are the zeros. These are the answers to our factors. So first, let's set them up in factored form. And we would get f of x. Oh, goodness. Let me go back. So f of x equals x plus 2. Remember, because for a 0, it's opposite of what we think. So we need to start with x plus 2. The next one is x plus 1, then x minus 1, and then x minus 2, because what you have at the top are the answers, and these are the factors that they came from if we set them equal to 0. Now, I do boxes typically to multiply. So if I put these two together, I would get, if I, some of you like to use full, whatever, but you would get x squared plus 3x plus 2. Okay, and then the second one would be x squared minus 3x plus 2. And then for us, I'm going to take it a step further, and then I'm going to multiply those two together. Now, on this one, I can't just do that one in my head, so I'm going to create a box for all of them. So we have x squared, we have 3x, and we have 2. You have x squared, we have negative 3x, and then we have 2. Okay, that will give us x to the 4th, negative 3x cubed, and then I have 2x squared, and then 3x cubed, negative 9x squared, and then 6x. Last column is 2x squared, negative 6x, and 4. Okay, if you look on your diagonals, they are or should be like terms. So I see some cubes right here that are like terms. I see some squares that are like terms here. And I see just some x's that are like terms there. So in the end, our answer will be, if I combine like terms, I'll have f of x equal to x to the 4th. As far as my cubes go, they cancel each other, so I don't have any cubes left. 2x squared minus 9x squared is really negative 7x squared, and then negative 7x squared plus another 2x squared is negative 5x squared. As far as the x's go, 6x minus 6x, they cancel, and then I'm just left with positive 4. So this is the answer that I got for multiplying those functions together, or multiplying those zeros together. Okay. I will need space to do the second one, so I'm going to need to erase all of this in order to do what I need to do. So I need to erase all of this. All right. Now, with that being said, we're going to take a look at our next function. Okay, now remember, these are answers. So to get 3, you had to have started with x minus 3. Now, these conjugate ones are pretty tricky, but I don't want you to be tricked by them. Remember, it's always x minus. So this is x minus, and then I'm going to put this in parentheses as 2 plus the square root of 11. And I have another one that's x minus, but this time it's 2 minus the square root of 11. Okay, so before we even start really trying to multiply, what I want to do is I want to deal with these conjugate looking ones. So I still have x minus 3. If I distribute this negative inside, I will have x minus 2 minus the square root of 11. And then if I distribute that negative, I will have x minus 2 plus the square root of 11. All right, then from there, I will put my two conjugates together because they will cancel out better than if I put the x minus 3 in front. So it's going to look like a trinomial by a trinomial, but it's really not. You'll notice that a lot is going to cancel. So here we go. We have an x, a -2, and a negative square root of 11. Then I have an x, a -2, and a positive square root of 11. So that's going to give us x squared, -2x, x square root of 11. Then -2x, +4, and -2 square root of 11. And then the last one is -x square root of 11, +2 square root of 11, and then a square root multiplied by itself is just a radicand, which is 11, but this one was negative, so it makes it -11. And like I said, you should have a lot to cancel. So this x squared of 11 will cancel with that negative x squared of 11, and I'll also have a -2 squared of 11 that cancels there. And then from there, everything else is like terms. So that will be x squared. The -2x and the -2x will give you -4x. And then the 4 and the -11 will give you -7. So that's the first part of our function. So now we have x minus 3 times x squared minus 4x minus 7. Okay, so this is going to be a trinomial. So x squared minus 4x minus 7. And it has x and -3 on the bottom. So this gives me x cubed. If I multiply, -4x squared, -7x, -3x squared, 12x, and +21. So the final answer there, when I take it out, is f of x equals x cubed minus 7x squared plus 5x and then plus 21. And again, there are many correct solutions. This is just the way that I'm doing it to give us this answer. Let's try the next one. So we want you to find the polynomial function with -1/2, 3, and 3 as a 0. So again, let's start with f of x. If you have -1/2, that came from x plus 1/2. And then we have as 3's, they would come from x minus 3 and x minus 3. Okay, starting with those two, because they're fairly simple, that'd be x plus 1/2 times x squared minus 6x plus 9. All right, then from there we can use the box. Don't be afraid because you see a fraction. If you want to, you can change it to a decimal. It doesn't matter, but I'm going to leave mine as a fraction. So that would give me x cubed. This would be 1/2 x squared. This would be -6x squared. Then -3x, because -6 divided by 2 is -3. 9x and then 9/2. And again, look at your like terms. So f of x will equal x cubed. As far as your x squareds go, that'd be -5.5 x squared, because -6 plus 1/2 is -5.5, and then plus 6x, and then plus 9/2. All right, let's take a look at our very last one. So it says, sketch the graph of f of x equals 3x to the 4th minus 4x cubed by hand. I know this says sketch, but I actually want you to do a very good sketch. So it's almost really like just graph it. But the first thing that we want to take a look at is we want to kind of just pretty much just do everything that we've done up to this point. First thing that we want to do is we want to find our zeros, or where are they going to cross the x-axis, or even better, what are their x-intercepts. So we do that by setting our function equal to 0. Okay, I can factor out an x cubed, and I'm left with 3x minus 4. So that means x cubed is equal to 0, which means I get 3 zeros from that, right? And then if I set 3x minus 4 equal to 0, that means I get 4/3. And that one just has a multiplicity of 1. So this one Again, like I said, it has a multiplicity of 1. It's odd, so that means it's going to be a chest pass. Means it's going to go straight through 4/3. This 0 is also odd. It has a multiplicity of 3. And it's also going to be a chest pass. Okay, so those are our those are our zeros. So the x-intercepts of those, by the way, are 0, 0, and 4/3 0. That's what they represent. Also, something else that we want to point out, because the leading term is 3x to the 4th, because it's to the 4th power, remember that means it's an even power, so they should end the same, and it's positive, so this one is going to be an up and up. And then the last thing that you want to do is you want to choose values that surround these values here. So I want to pick a number on the left of 0. I want to pick a number between 0 and 4/3, and then I want to pick a number on the right of 4/3. So a number on the left of 4/3 would be -1. So if I substituted -1 back into our function, I would get a value of 7. So that means that that ordered pair is -1, 7. So that's another point that I have. A number between 0 and 4/3 is 1. So 3 times 1 to the 4th minus 4 times 1 cubed. That would give you -1. So that value is 1, -1. And then the last one, a number that's greater than 4/3 could be like 2. So that'd be 3 times 2 to the 4th minus 4 times 2 cubed. And that gives you 16. So that value would be 216 if I plot it. All right, so for us to sketch, and again, this isn't really a sketch, it's just a fairly good graph. I'm going to plot some ordered pairs. So remember, something is going to go through 0, 0, so that's at the origin. Then something's going to go through 4/3 0, so that's like a 1 1/3, so that's about there. Then you have a point at -1, 7, so 1, 2, 3, 4, 5, 6, 7 would be up here somewhere. I have another graph or a point at 1, -1, so 1, -1 is down here. And I have another point at 216, which is off of our chart. And because I know that this is up and up, I can sketch my graph to look something like that. And you could double check that on your graphing calculator to see that you would get something that's pretty much just like it. So again, the first thing that we started with was factoring. That gave us our zeros, which in other words gave us our x-intercepts. Then we tested points around those numbers. So I chose a number less than 0, a number between 0 and 4/3, and a number greater than 4/3. Plotted the points, and then that was it. So we're going to try that again. On our last one, we have to set this equal to 0. So 0 equals -2x cubed plus 6x squared minus 9/2 x. Okay. If I factor a half out of everything, specifically if I factor a -1/2 out of everything, I'm left with 4x squared minus 12x and then plus 9. Okay. This here, if I did AC, AC would give me 36. So the factors of 36 that are going to give me 12 are -6 and -6. So when I rewrite this, this is -1/2 x, and then 4x squared minus 6x minus 6x plus 9. Group those two. I get 0 equals -1/2 x times, I can take out a 2x, and that leaves me with 2x minus 3. I could take out a -3 from the second one, and that would be 2x minus 3 as well. So when we are done, you have 0 equals -1/2 x times 2x minus 3 and another 2x minus 3. So if I set all those equal to 0, and by the way, this is really -1/2 x times 2x minus 3 squared, because that gives you multiplicity. If I set this 0 equals negative 1/2 x, my x for that one would be 0. If I set this equal to 0, I would get 3/2. But it has a multiplicity of 2. And remember, if it has a multiplicity of 2, that means it is going to be a bounce pass. It means it's going to bounce back up. So again, I should choose values on the left and right of that. So I should choose a -1, I should choose a 1, and then I should choose a 2. I've already done the work, meaning I should substitute them back into my original function. So if I substitute -1 into my function, I'm going to get 12.5. If I substitute in 1, I will get -0.5. And if I substitute in 2, I will get -1. Okay, so with that being said, first thing I want to do is plot all my points. Oh, let me go back. The leading coefficient test, this says this is cubed, so this should be opposite, and because it's negative, a negative slope goes from up to down. So this should be an up and down type of graph. Okay, so I should have by the way, yours should look a lot nicer because yours are actually on graph paper. All right, so the first thing I'm going to start off with are my zeros. That's 0, 0, and 3/2 0, which is 1.5. Remember, at that second point that I just plotted, it will bounce up at that point, either bounce up or bounce down. And at the first one, it goes through. So I have a point at -1, 12.5, which is somewhere way up there. I have a point at 1 and -0.5, which is a little under. So if you can see it. And then the last one is at 2, -1. So I can kind of see that it's going to, again, it's going to go through my first 0, but it's going to bounce at my second one, so it bounces down. And so that's a sketch of that function. Guys, if you have any questions, please be sure to come in and see me.